Okay.
Well, Kit.
Hi, friend. How are you?
Nothing less than superb.
That's a common answer.
Yep.
This is my good friend, Randall Ness, who I've now worked with for
25, 26 years?
yeah, 25
years.
years.
25 years.
Yeah.
Yeah, wow, our quarter century mark.
Yeah. Randall's taught me a lot. So I thought we should record a conversation briefly. Where are we at today, Randall?
Put me on the spot on YouTube. Oh my gosh, all these people.
We're at the Executive Briefing Center in Poughkeepsie, New York.
Oh, you meant physically. I
Physically.
thought you meant metaphysically.
No,
oh my gosh.
no, I didn't mean that hard of a question. We're at the Executive Briefing Center in Poughkeepsie, New York, IBM's. This is one of the ground zero for one of the kinds of systems Randall and I have worked on a good portion of our career, and the mainframe systems. I think they were probably, I don't know the history very well, but I suspect they were originally, some of the original ones were constructed, manufactured here on these locations.
This is the place.
This is the place.
Yeah.
So, thanks for showing up. We have some meetings here today. So, Randall, tell me about some of the history that we've worked on.
Well, let's see. It's been a very
What'd you say yesterday?
What?
On our
A
travel,
long, strange trip this has been.
Strange trip this
to
has
quote
been.
the Grateful Dead.
Yes.
What
Yeah.
a long, strange trip this has been.
Give a little bit of your background, Randall. Why would I have a conversation with you? What brought us together, and what have you done over 25 years? What's your area of expertise?
Well, let's see. So, about 25 years ago, we built a cosmic universal data extractor.
Okay.
Yes.
Yeah.
And since then, we've been solving major high-volume data extraction and reporting problems throughout the world.
Yeah. At the time, it was called Geneva. That's the name of the tool. It stood for Generalized Event Architecture. It was kind of, you pick the characters apart, and
Mm-hmm.
you got to that name.
Yeah.
When we came into IBM, we had to change the name because you couldn't trademark a city name, and so it became SAFR, Scalable Architecture for Financial Reporting. Right?
Yep. Yep.
And what's your role? What's your your responsibility?
Well,
towards
my
it?
current role is chief architect. I help design the software and add new features, manage the programmers, manage the support.
Yeah.
Yeah.
So Randall, one of our first things Randall taught me to do, he was the experienced guy that knew how the system worked.
Yes, I used to be his coach.
He was my boss. He was my coach, my boss. We had to build some production JCL for the system. One of our first all-nighters was when
Yeah.
a customer required the JCL to run the system. They wanted to install and run it, and we didn't really have anything that was production ready.
Yep. Yep. Well, one of the first of many all-nighters I've had with Kit.
Yes, there was quite a few of those.
Yeah.
We felt we were part of Price Waterhouse at the time, and it's a big company, but we kind of felt like we were a little startup in a garage there in Sacramento, California.
Yeah.
We kind of operated that way, kind of
Yeah.
like a startup
It
company.
was fun, and we had pizza every night practically.
Yes, yeah.
Getting us through the system testing cycles. Yes.
Yes, we did.
Yeah.
Yeah. So, where did SAFR come from? Where did Geneva come from? Give me the history before my time.
Well, am I allowed to say client names and things like that?
Yeah, I think for the most part, I don't think those people are going to care at this point. So yeah.
Well, okay. It actually, the original idea started coming out of the Alaska State Department of Finance in the early 1980s. There was a big project that Price Waterhouse was doing up there, where they were flush with oil money at the time, and they said, Price Waterhouse, come up here and build us a Cadillac accounting system. And so the Seattle office was in charge of that project, and my original boss, Gary Larson, sold that project, and it was a very productive project for the course of 5 years, where they built an accounting system that ended up lasting 30 years up there in Alaska, which was very impressive.
And what was one of the principles behind that made it unique?
Well, I think it's that it was very high performance reporting, and they were able to. Funds accounting in state government is very difficult. It's hard to bring together all these different streams of data, and trying to think of all the different summarizations and roll-ups people wanted to have. So the thing that they did is they gave the users the flexibility to design their own reports. So I think that was the thing that kind of set that apart. It was all mainframe based at the time because that's all we had, but it was really kind of innovative in its design techniques, and accomplished a lot.
Let me add to that. One of the
Sure.
key things that I think about that was that they recognized they couldn't maintain the summaries on an ongoing basis, and so they built it high performance so it could scan the detail transactions journals every time it needed to produce a report.
Mm-hmm.
And that was why it basically was built upon an event-based principle,
Mm-hmm.
is what kind of started us down this road of recognizing they had to do that sort of work
Mm-hmm.
in that way. I think we're getting a call
I think
from the caller.
Jim's trying to find us. Hey Jim, I'm on YouTube right now.
I can edit that out.
Yeah.
Maybe I won't.
Okay.
So that was one of the things that I think was the key about it, was the development of that.
I didn't know they had actually gotten to that point at that project.
Yeah, because it was the idea that every night there's like, I don't know how many accountants around the state could log into the system and could define their own reports.
The number I heard was like 250
Yeah,
all the time.
so I knew it was in the hundreds. So yeah, okay. So then from there,
Well, okay, so a lot of concepts for how to solve this big, large-scale reporting problem were solved during that project. And then, well, one of the key persons on that project was Rick Roth, who was our boss for many years. And so he was a Pricewaterhouse senior manager at the time, and later became partner. But so he took a lot of those ideas, and he, well, another key person was Doug Kunkel, who was hired in 1983 at that time to solve some of these problems, because he was an ace assembler programmer, and he knew how to get the machine to sit up and bark. So he could make it go through hoops and do wonders. So
he could code on bare metal.
he could code on bare metal. Yes, Doug coded on bare metal. Anyway, so that then those two guys really solved a lot of problems. And then a few years later, in 1987, the state of Oregon Department of Transportation had some similar problems. The federal government had been giving them money to fund all their transportation construction activities across the state, and the federal government told the state of Oregon that their books were not auditable, and if they could not get their books auditable, they would want to have $27 million back. And so there was a crisis there, and of course at the time the controller for the Oregon State Department of Transportation was a fellow named Doug Goldbach, who actually knew Rick and Doug from up in Alaska, and he said, "Get me those guys, get me those guys." So we started a project down at the state of Oregon, and basically took those concepts and kind of like took them one step further, and so basically added on to it, and that really was probably what we would call Geneva version 0.
Yeah, okay.
It really was a lot of the same code, and we ended up really kind of expanding the whole idea of letting the user have the flexibility to design their own reports and design on a screen what they wanted to see in all these big batch reports. And so that turned out to be a very big success for them, and they were able to prove to the federal government that their books were auditable, and so it saved them $27 million.
And we actually took later on, 93, we took back the code, the Geneva version 0, back to Alaska and installed it there.
That's right.
And that's what ended up they used for a lot of years afterwards.
Yeah.
The first version got replaced by the...
No, not the whole account
Not the whole
system,
account,
just
but
the reporting
just the
piece.
reporting
Just the
piece.
reporting piece. And then Around that time, well, let's see, around 1989, the state of Wyoming said, well, we have a very similar problem. Why don't you come over and straighten out our Department of Transportation? So some of the teams started migrating over there over the next couple of years, and then pretty soon we set up another project over there where we set up a large accounting system for them. And
one of the things Rick told me one time was, he said, listen, in that day and age in the 80s, no one was doing enterprise-wide work. All systems were developed as like a department system or a division system. Nobody tried to do anything for the entire. But he said these mandates from the federal government to these states are the ones that forced them to do some of these things, because they had to, for the audit requirements, they had to report on the state in total. Mm-hmm. And so that's why it was somewhat developed out of that space, because it required scale, because they were dealing with large volumes of data, because they had to deal with the enterprise in total. Mm-hmm. Is one of the explanations.
Yeah, right. So anyway, so then that project became a very large success. So around that time, we started thinking that, maybe we've solved this problem in a unique way that nobody else has thought of, and we should see if we could take these ideas and take them around the world. So at that time, we decided to start commercializing the software and selling it to other firms besides government entities.
Yeah.
And right off the bat, we obtained a client which was a very large retailer at the time.
Yeah.
Very large retail firm, and they were creating a customer marketing database. Actually, they had one running for a few years, and they had a very highly tuned COBOL program that would scan the last 2 years' worth of transactions and look for patterns and look for things that people were buying. And if people were buying hiking boots, well, they'd send them camping equipment catalogs, and they were doing targeted marketing and things like that. And so this is such a big process that it would take 25 hours to run, and so they could only run on the weekend. And so they did that. And so we took a look at that and we said, well, we think we could do better. So we went in there and applied our Geneva software at the time to that problem and solved it and produced the same results in less than an hour.
It was 40, I think Jay Paulus predicted 45 minutes, and it ended up being 43 minutes, the actual runtime. If I've got that right.
So they realized we were magicians.
They wondered at first if we tricked the operating system somehow to record the time less, but no, it just was you do things in a more efficient way, and substantial changes are possible in what you can do.
Right, and so that led to a series of projects out there. I think at one time we had maybe 4 projects going out there.
And they used the software for over a decade.
Yeah.
Or more.
Right.
For those different problems.
Right. And so it solved some major problems there. And so that kind of led to other projects that we did at other large U.S. firms. A large cookie manufacturer.
Yep.
Around that time.
A very large chip manufacturer.
Yes.
Computing chip manufacturer. You spent a number of years.
I did.
There.
And that was a sales reporting system connected to SAP software. What they were figuring out is that they'd solved the problem getting all the data into the system, but they couldn't get it out of the system fast enough to be able to solve their problems. I mean, it seemed like some of their reporting processes were taking more than a day, which is kind of hurting if you're...
Well, they had 3 around the world. They closed their books every 8 hours in the U.S., in Asia, and then in Europe. And when you have a day-long cycle in an 8-hour window, it doesn't work.
Right.
So right. The premise behind the ERP software was that, listen, if we get all our data in the same code sets and we get it into the same database, then it'll solve the reporting problems. But that's not true, because now you've just got a lot of data sitting in the same place, and the process of going through and creating balances and creating reports off of that took too long. And just having the data in the database didn't solve the reporting problem.
Right.
Our cookie manufacturer was also an SAP implementation where they had a similar problem. So over the years, we've had, I don't know, a couple dozen either. I don't know that they were all production clients, but we've had projects that use the software for 20 different types of problems, different industries, airline industries, insurance. financial services,
Pharmaceutical industry.
pharmaceutical industry for an antitrust suit where they had to prove what their pricing policies were for 12 different pharmaceutical companies were using the software as
Yeah.
part of that. It's been a, let's see, what did you call it? A long, strange...
What a long, strange trip this has been. You've never heard that song?
Yeah, no, I know the song. So on the way in here, Randall reminded me that he was kind of in Poughkeepsie, not at this executive briefing center, but someplace like this.
Up on the hill.
22
years ago.
years ago. So talk briefly about what was that? What did you do then?
Well, the whole idea was IBM had been making machines bigger and bigger, but they figured out that they couldn't make the chips any larger without having extreme heating requirements. So that they switched over to a new technology called CMOS technology, complementary metal oxide semiconductor, I guess.
Very well said.
Thank you.
This early
Yes.
in the morning.
Yeah, oh, amazing. I'm on Pacific time.
Yeah.
Okay, so that was what was going on in IBM at the time, that they were switching over to systems which could have more processors, but not as powerful processors. Rather than making big, large, monolithic processors, they were going to try to make cheaper and more efficient and air-cooled processors rather than water-cooled processors at the time. But they were trying to find ways of doing the same things they always had been doing in more efficient fashion. And so I came up here and was working on showing how we could use SAFR to solve some of these problems on the new hardware technology.
And when you ran the system, what was the result? When we put SAFR on the system?
Well, it turned the lights out.
They were amazed, weren't they?
Yeah, they were.
They really ran the channels and it ran the whole box at a very consistent rate over a sustained period of time, and they hadn't seen processes that ran that sort of way.
Yeah.
Yeah, that's been kind of your experience in a lot of places.
Right.
When we get a chance to solve a problem,
Yes.
people are pretty amazed at what the software can do.
Yeah.
Yeah.
And I think, one of the things we've learned over the years is that it really makes sense to hang on to the detail, because you never know what you'll need later on. If you start summarizing out the detail at the beginning, then later on you figure out, well, I'm missing that data item that I needed. I wish I still had that.
Yeah.
So
Yeah.
the key is really to develop systems that can do sequential scans really quickly and efficiently. And that way you never lose the detail, you never lose the data items that you may need later on. Because regulatory requirements change.
Well, people's interests change. You realize that there was something about the data you had captured that will provide you new benefit. Understanding your customers, understanding your products, understanding your markets. Those kinds of things change over time.
Right.
And that information, that history, just like our discussion here today, the
Yeah.
history can be helpful in understanding where we're going.
Yeah.
And keeping that history, keeping that detail is important.
Right. So we're into just-in-time reporting, just-in-time requirements.
Off of the detail.
Yeah.
Thank you, Randall.
You're welcome, Kip.
It's been pleasant chatting with you again. So early in the morning. Thanks for chatting with me.